Good morning, students. Is it visible? Is my screen visible to you? Hmm. Okay, today's topic is very important with respect to our internal examination as well as external examination. Linear variable differential transformer. Differential, we can call this as a transducer or transformer. Linear variable differential transformer or transducer. That is, we can call this as LVDT. In short, we can call this as this transducer. We can call this as linear variable differential transformer or a transducer. In short, we can call this as LVDT. Okay, this is a linear variable differential transducer is also called as linear variable differential transformer. It consists of, this is the structure of LVDT. It consists of, these are the windings. This is the primary winding. These two are secondary windings, S1 and S2. Here also, this is the secondary winding S1. This is secondary winding S2. This is the primary winding P. This is the primary winding P. Across the primary winding, we are going to give some AC excitation signal. Input signal is going to be given at primary winding. Transformer కు మనం primary winding ఏ కదా AC input signal ఇస్తాం. Primary side ఏ కదా ఇచ్చేది AC input signal. అట్లాగా for this primary winding, I am going to give some AC type of input signal and I am going to acquire the output across the secondaries. Output across the secondary windings, and the output across this secondary winding S1 is ES1. Let it be that that output that output EMF I am going to acquire is voltage potential I am going to acquire is ES1, and whereas here at secondary winding ES2. Primary winding it is a primary winding. I am going to give the some AC excitation signal, and depends upon the soft iron core movement, I am going to acquire the resultant output voltage in terms of secondary voltages. In terms of secondary voltage, I am going to acquire here, that is across the secondary winding S1, that is ES1, across secondary winding S2, that is ES2. This is the arm. Depends upon the arm movement only, I am going to get the variation in the secondary winding voltages. Arm displacement, due to the arm displacement, I am going to acquire the variation in the secondary winding voltages. That is, this is one form of diagram, and this is the another form of diagram. You need to draw this diagram in your exam like this. Okay? This is for our understanding sake. For our understanding sake, I am given like this. Okay, from this is the core material, and this is the arm, and displacement of the arm will take place. This is the secondary, primary. AC excitation AC excitation signal I am going to given across this primary winding, and secondary winding S1, secondary winding S2, and the potential developed across this S1 is ES1, and potential developed across this one is ES2. This is the construction part, LVDT construction part. Okay, and we will see this theoretical part. It consists of primary winding P1. It consists of primary winding P1 or P. Okay, and two secondary windings S1 and S2 on a cylindrical former. This is the two secondary windings S1 and S2. These secondaries have an equal number of turns. ఆ secondaries కి ఇప్పుడు నేను ఇంకొక డయాగ్రామ్ చూపిస్తాను. This is the another diagram. This is the another diagram. This is I am taking one coil. I am taking one coil, and the wire is this is the wire is wounded upon this coil. Then when a coil is placed in the and a carrying coil is placed in the magnetic field, it is going to give some output potential like that. That same principle is applied here. Here, this is the primary winding. In a central position of this coil is primary winding. It is going to give some E input. I am going to I'm going to give some potential En here, and this is the A and B is the core material. This is the secondary winding. This is the secondary winding, and this is the secondary winding, and the resultant voltage across these two secondary windings is E naught. E naught. Let it be. This is the another. This is the cross sectional view. Anukunte. This is the another view. Basic circuit. This is the constructional part like this, and this is the primary winding. Primary winding, AC type of input signal is given here, and core material, and this is the arm, displacement of the arm, and this is the secondary winding. Voltage potential is given here, ES1 and ES2. Okay, resultant is E naught. Resultant is E naught here, and this is the some more clear view of the same diagram is given like this. AC type of excitation input signal is provided for primary winding. Arm the arm movement will take place in this direction. Core material, core material, and secondary potentials is ES1, ES2, and the resultant E naught, the differential output voltage is given by ES1 minus ES2. Okay, in this way, the working of LVDT can be explained. We will see in detail. In detail, what is the working of LVDT? The secondaries have an equal number of turns, but they are connected in series. Series in opposition, so that the EMF induced in the coil oppose each other. This this coil this coil these two coils in opposition in direction. This EMF the EMF possessed by this secondary coil S1 is opposite to the secondary coil S2. Therefore, the phase angle between these two secondaries is 180 degrees like that. Okay, the primary winding is connected to an AC source whose frequency range is from 50 Hz to 20 kilohertz. The frequency range is from 50 Hz to 20 kilohertz. Okay, we know the movable soft iron core slides inside the hollow former. Soft iron core is going to be moved inside the hollow former. The position of the movable core determines the flux linkages between the AC excited primary winding and each of the two secondary windings here. The flux linkages is going to be takes place between these primary this primary winding as well as this secondary winding. This is about construction part, and uh, the core made up of nickel iron alloy is slotted longitudinally to reduce eddy current losses. In the lengthwise fashion, this core material is going to be aligned here. This core material is made up of nickel iron alloy type. Nickel iron, this core material is going to be manufactured with core nickel iron alloy type. The displacement to be measured is applied to an arm attached to the core. The displacement is going to be measured. The displacement to be measured is applied to an arm attached to the core material. When the core in the center or the reference position, center position ఏమో మనం reference position అనుకోవచ్చు, or reference position అనుకోవచ్చు, or null position కూడా అంటారమ్మా ఆ reference position. The induced EMFs in the secondaries are equal. This reference position or null position, the induced EMF in the secondaries are equal. Therefore, the output differential voltage is going to be zero. Since they oppose each other, the output voltage will be 0 volts here. When the core in the center or reference position, the induced EMF in the secondaries are equal. And since they are opposite, these two voltages are in opposite direction, the output voltage will be 0 here. When the externally applied force moves the core to the left hand side, to the left hand position, ఈ కోర్ మెటీరియల్ లెఫ్ట్ హ్యాండ్ పొజిషన్లో మూవ్ అయితే, ఈ కోర్ మెటీరియల్ ఎక్కువగా ఈ లెఫ్ట్ హ్యాండ్ పొజిషన్ మూవ్ అయితే that core material when external applied force moves the core to the left hand position, more magnetic flux linkages the left hand coil than the right hand coil. ఈ కోర్ మెటీరియల్ ఇటువైపు మూవ్ అయితే ఇక్కడున్న మోర్ లింకేజెస్ మ్యాగ్నెటిక్ ఫ్లక్స్ లింకేజెస్ ఈస్ మోర్ అక్రాస్ దిస్ సెకండరీ వైండింగ్ ఎస్ వన్ దగ్గర ఫ్లక్స్ లింకేజెస్ ఎక్కువగా ఉంటుంది. అక్కడ వచ్చిన పొటెన్షియల్ ఎట్లా ఉంటుంది, హైగా ఉంటుంది అనమాట వెన్ కంపేర్ టు ది ES2. అప్పుడు ES1 ఈజ్ గ్రేటర్ దాన్ ES2 అని చెప్తాం అనమాట. ఈ కోర్ మెటీరియల్ లెఫ్ట్ హ్యాండ్ సైడ్ జరిగితే ES1 ఈజ్ గ్రేటర్ దాన్ ES2. అదే దిస్ కోర్ మెటీరియల్ ఈజ్ మూవ్ టు ది రైట్ హ్యాండ్ సైడ్. This core material is moved to the right hand side. Then this secondary winding voltage, and then the secondary winding potential is going to be greater than this greater than this S1. That means ES2 is greater than ES1. ఇది లెఫ్ట్ హ్యాండ్ లెఫ్ట్ హ్యాండ్ సైడ్ మూవ్ అయింది అనుకున్నామా. లెఫ్ట్ హ్యాండ్ సైడ్ మూవ్ అయితే ఐఎమ్ గోయింగ్ టు అక్వైర్ ది ES1 ఈజ్ గ్రేటర్ దాన్ ES2. Whereas if this core material is moved towards the right hand side, then ES2 ES2 is greater than ES1. అదే నల్ పొజిషన్లో ఉందనుకోండి, ఇక్కడ ఈ పొజిషన్లో ఉంటే ఈక్వల్ దిస్ ES1 ఈజ్ ఈక్వల్ టు ES2 అవుతుంది అనమాట. అది this is the entire working. This is the basic relation, and this is very useful. ఈ 3 కేసెస్ అనమ్మా మనం డిస్కస్ చేసేది ఎంటైర్ వర్కింగ్ LVDT వర్కింగ్లో. The EMF induced in the left hand coil ES1 is therefore greater than ES1. Left hand side move అయినప్పుడు ES1 is greater than ES2 here. Okay. When the magnitude of the output voltage is then equal to the difference between the two secondary voltages and it is in phase with the voltage, that is left hand coil. Okay, similarly when the core is forced to move to the right, more flux linkages the right hand coil than the left hand coil, and the resultant output voltage, which is the difference between the ES2 and ES1 is now in phase with the EMF of the right hand coil. It is going to be in phase, whereas left hand side is out of phase, like that. Okay, when the core is at center, we get output voltage as 0 volts. When it is this position we may call this as null position here of LVDT. The output voltage of LVDT is given by V out is equal to ES1 minus ES2, where ES1 is the output voltage across secondary winding S1, ES2 is equal to output voltage across secondary winding S2. Okay, V naught is equal to ES1 minus ES2 అయినా చెప్పి ES2 అయినా రాయొచ్చమ్మా. Next one, so null position ES1 is equal to ES2 when output, then the output voltage is going to be 0. When the core is moved from the null position, the induced voltage in the corresponding secondary winding towards when the core is moved increases when the induced voltage in other winding decreases. ఒక వైండింగ్లో ఎక్కువ ఉంటే ఇంకొక వైండింగ్లో తక్కువ ఉంటుంది అని చెప్పి చెప్తున్నారు అన్నమాట పాయింట్. Then the differential output voltage is given by V out is equal to ES1 is approximately difference approximately ES2 available here. The differential output voltage varies linearly over a considerable range on both sides of the null position in accordance with the change in the core position. The LVDT output voltage is a function of the కోర్ పొజిషన్. ఎల్విడిటి అవుట్పుట్ వోల్టేజ్ దేని మీద ఉంది, ఆ కోర్ పొజిషన్ని మనం ప్లేస్ చేసేదాన్ని బట్టి ఉంటుంది అనమాట. LVDT output voltage depends upon the core position. This is the key point. The key point. The amount of the voltage change in either secondary winding is proportional to the amount of the movement of the core. అది చేంజ్ ఇన్ ది అవుట్పుట్ వోల్టేజ్ ఇస్ ప్రపోర్షనల్ టు ది మూమెంట్ ఆఫ్ ది కోర్. ఈ పాయింట్ని బట్టి ఈ పాయింట్ని మనం చెప్పొచ్చు అనమాట. And by noting which output is increased or decreased, the direction of the motion can be determined. The output AC voltage, the output AC voltage inverts inverts in phase as the core passes through the central null position. The output AC voltage inverts in phase. The output AC voltage అంటే ఇన్వర్షన్ పొజిషన్లో ఉంటుంది కాబట్టి ద కోర్ ప్రాసెస్ టు ది సెంట్రల్ నల్ పొజిషన్ తీసుకుంటే ఏంటంటే సెకండరీ వైండింగ్స్లో ఉన్న రెండు పొటెన్షియల్స్ కూడా జీరో అవుతుంది అన్నట్టు చెప్తున్నాడు అనమాట. ఫర్దర్ హ్యాస్ ద కోర్ మూవ్స్ ఫ్రో ది సెంటర్ పొజిషన్, సెంటర్ పొజిషన్ నుంచి మూవ్ అయితే ఏంటంటే అది ఇటువైపు మూవ్ అయితే సెకండరీ వైండింగ్లో S1 మూవ్ అయితే ఎస్ వన్ వైపు మూవ్ అయింది అనుకోండమ్మా, సెకండరీ వైండింగ్ S1 వైపు మూవ్ అయితే దట్ పొటెన్షియల్ అక్రాస్ ది S1 ఈస్ హయ్యర్. వెరాజ్ S2 వైపు మూవ్ అయింది అనుకోండి, ద పొటెన్షియల్ అక్రాస్ ది S2 ఈస్ హయ్యర్. లైక్ దట్ we are telling that position, that movement as left hand side as well as right hand side, like that. Further, the movement moves for the center, the greater is the difference in values between the ES1 and ES2, and consequently, the greater the output voltage. Therefore, the amplitude of the output voltage is a function of the distance the core moves. The core moves, while the polarity or the phase indicates the direction of the motion. The amount of the output voltage of an LVDT is a linear function of the core displacement within the limit range of motion. 5 వరకు వీఆర్ గోయింగ్ టు అప్టైన్ ది లీనియర్ కర్వ్ అనమాట. 5 డిస్ప్లేస్మెంట్ వర్క్ ఏంటంటే మనకి లీనియర్ కర్వ్ వచ్చింది. అబోవ్ 5 చేసాం అనుకోండమ్మా, అది డీవియేట్ అయిపోయింది అనమాట. లీనియర్ కర్వ్ కాస్త బెండ్ అయిపోతుంది అనమాట. అది మనం చూస్తాం ఫర్దర్గా. దిస్ ఇస్ ది ఫస్ట్ వన్. దిస్ ఇస్ ది ఫస్ట్ పొజిషన్. This is the first I will take this position, core at zero position, core at zero position. This is the position, output voltage at a null position here. This is the point. And if the core moves towards the left hand side, towards the left hand side, that means core at a position, core at a position, then this is the phase angle for this one is phi is equal to 0 degrees. Linear graph I am going to obtain here, and this is the residual voltage. Inside some residual voltage will takes place here. ఇక్కడ వరకు నాకు లీనియర్గా వచ్చిందంటే 5 వరకు, బిలో 5 ఐఎమ్ గోయింగ్ టు అప్టైన్ ది గ్రాఫ్ లీనియర్లీ. అబోవ్ దిస్ 5 ఐఎమ్ గోయింగ్ టు ద డీవియేషన్ పార్ట్ విల్ టేక్స్ ప్లేస్. అబోవ్ 5 చేస్తే డీవియేషన్ వస్తుంది అనమాట. దిస్ ఇస్ ద డిస్ప్లేస్మెంట్ ఏ పాయింట్ అండ్ this is the A point. Similarly, here the output voltage out of phase. This across this A point, ante this is across this A point. The output voltage is out of phase here. Point A దగ్గర, point A, that is phi is equal to 0 degrees out of phase will takes place. That means here I can give it here. What is the relation? Core A position ES1 is greater than ES2. ES1 is greater than ES2, whereas here core at B position ES2 is greater than ES2 is greater than ES1. Here ES1 is equal to ES2. Okay, this is the three positions. And at core B, if the core moves towards the right hand side, then ES2 is greater than ES1. Then at this point B, 180 degrees phase shift will takes place here. That is Here at this B position, in phase will takes place, whereas at a position out of phase will takes place. This is the core position of LVDT and variation of output voltage with respect to the displacement of the core material. Okay, this is very important. This is the entire working, and this is memorizing of this one is also very easy. Okay, by noting this diagram as well as by drawing this graph, you will get good marks. Okay, next one, this is the actual diagram for the LVDT. This is the core material, primary windings. These two are primary. This is the primary winding, and this is the secondary winding. This is primary, secondary, secondary. And this is the core material is made up of nickel iron core material, and this is the high permeability magnetic shell. This is high density glass filled polymer type of coil, and this is entire housing is stainless steel housing and end caps here. This is the epoxy. This is one type of epoxy. This is black shade given here. This is the epoxy type of encapsulation. దిస్ ఇస్ ద మనకు మామూలుగా అయితే ఇట్లా ఉంటుందమ్మా స్ట్రక్చర్, ఎల్విడిటి స్ట్రక్చర్. ఓకే, అండ్ దిస్ ఇస్ సమ్ సింపుల్ స్ట్రక్చర్ గివెన్ హియర్. దిస్ ఇస్ ఫెరోమాగ్నెటిక్ కోర్. అక్కడ నికెల్ ఐరన్ అయినా యూస్ చేయొచ్చు, ఫెరోమాగ్నెటిక్ కోర్ అయినా యూస్ చేయొచ్చు అనమాట. ది ఎంటైర్ హౌసింగ్ ఇస్ మేడ్ అప్ ఆఫ్ స్టెయిన్లెస్ స్టీల్. దిస్ ఇస్ ద ప్రైమరీ కాయిల్. దీస్ టూ ఆర్ ది సెకండరీ కాయిల్. దిస్ ఇస్ అనదర్ టైప్ ఆఫ్ డయాగ్రామ్. ఓకే, ఫర్ నోయింగ్, ఫర్ నాలెడ్జ్ సేక్ ఇది నేను చెప్తుంది, తెలుసుకుంటాం కోసం అంతే. And advantages of LVDT. First one is linearity. The output voltage of this transducer is practically linear for displacement up to 5 mm. Beyond that curve deviates here. Infinite resolution. The effective resolution depends more on the test equipment than on the transducer. ఎఫెక్టివ్ రిజల్యూషన్ అనేది టెస్ట్ ఎక్విప్మెంట్ మీద ఎక్కువ డిపెండ్ అవుతుంది అనమాట. హై అవుట్పుట్, ఇట్ గివ్స్ ఎ హై అవుట్పుట్, దట్ ఈస్ frequently no need for intermediate amplification devices. దీనిలో ఇంటర్మీడియట్ యాంప్లిఫికేషన్ డివైజెస్ యూస్ చేయాల్సిన పని ఏమీ లేదనమాట. ఇట్ ఈస్ గోయింగ్ టు గివ్ సమ్ హై అవుట్పుట్. High sensitivity. The transducer possesses sensitivity as high as 40 volt per mm. It is going to give the uh, 40 volts for the unit displacement like that. Maximum sensitivity is 40 volts like that. Ruggedness. These transducers can usually tolerate a high degree of vibration and shock. It is going to withstand with a high degree of vibration and shock also. That means it is very strong device. It is very strong device. Though I am making some vibrations or shock to the entire measurement measurement setup, it is going to withstand for that vibrations as well as shock. Less friction. There are no sliding contacts. Friction part అనేది చాలా తక్కువ ఉంటుంది. Why? Because the sliding parts is very limited. There is no sliding parts here. Low hysteresis. This transducer has a low hysteresis, low power consumption. Most LVDTs consume less than 1 watt of power. 1 watt of power కంటే కూడా చాలా తక్కువగా యూస్ చేసుకుంటుంది అనమాట అన్ని ఎల్విడిటీస్ కూడా. అండ్ disadvantages of this LVDT. Large displacements are required for appreciable differential output. లార్జ్ డిస్ప్లేస్మెంట్, ఎక్కువ డిస్ప్లేస్మెంట్ చేయాల్సి ఉంటుంది అనమాట. అప్రెసిబుల్ అమౌంట్ ఆఫ్ డిఫరెన్షియల్ అవుట్పుట్ వోల్టేజ్. దే ఆర్ సెన్సిటివ్ టు స్ట్రే మ్యాగ్నెటిక్ ఫీల్డ్. ఇది అంతా కూడా ఏంటంటే మ్యాగ్నెటిక్ ఫీల్డ్ కాయిల్తో రిలేట్ అయ్యింది కదమ్మా, అందుకని ఇది స్ట్రే మ్యాగ్నెటిక్ ఫీల్డ్ ఈస్ గోయింగ్ టు ఇట్ ఈస్ మోర్ సెన్సిటివ్ టు స్ట్రే మ్యాగ్నెటిక్ ఫీల్డ్ లైక్ దట్. ద రిసీవింగ్ ఇన్స్ట్రుమెంట్ మస్ట్ be selected to operate on AC signals, or a demodulator network must be used if a DC output is required. ఇది ఎక్స్ట్రా డిమోడ్యులేటర్ సర్క్యూట్ కూడా యాడ్ చేసుకోవాల్సి ఉంటుంది అనమాట మనం ఏదైనా డీసీ అవుట్పుట్ వోల్టేజ్ తీసుకునేటప్పుడు. అండ్ ద డైనమిక్ రెస్పాన్స్ ఈస్ లిమిటెడ్ మెకానికల్లీ బై ద మాస్ ఆఫ్ ది కోర్. డైనమిక్ రెస్పాన్స్ అనేది లిమిటెడ్గా ఉంటుందన్నమాట. ద డైనమిక్ రెస్పాన్స్ ఈజ్ గోయింగ్ టు బి లిమిటెడ్ మెకానికలీ బై ద మాస్ ఆఫ్ ది కోర్ అండ్ ఎలక్ట్రికల్లీ by the applied voltage like that. Temperature also affects the transducer. The maximum temperature it can detect is 300 degrees centigrade like that. Withstanding capability of this instrument is we can apply up to 300 degrees centigrade. Next one, application of LVDT is LVDT can be used in all applications where displacement range from fractions of a few mm to few centimeters. నుంచి millimeters నుంచి centimeters వరకు we can apply it for this LVDT. It acts as this LVDT is going to be used in most of the applications. It acts as secondary transducer. Okay, LVDT can be used as a device to measure. We can measure different parameters like force, weight, and pressure, acceleration also, etc. The force or pressure can be measured is first converted to displacement using the primary transducer, and then it can be applied to the LVDT like that. Then this displacement is applied to an LVDT that acts as a secondary transducer and converts the displacement into the proportional output voltage. ఆ డిస్ప్లేస్మెంట్ ని ప్రపోర్షనల్ అవుట్పుట్ వోల్టేజ్ గా ఈ నాట్ అనమాట, ఈ నాట్ గా మనకి ఇస్తుంది అనమాట. ఈ నాట్ ఈస్ ఈక్వల్ టు ES1 మైనస్ ES2 అట్లా ఇస్తుంది అనమాట మనకి అవుట్పుట్ వోల్టేజ్. దిస్ ఇస్ దిస్ ఈస్ అబౌట్ LVDT, లీనియర్ వేరియబుల్ డిఫరెన్షియల్ ట్రాన్స్ఫార్మర్. ఫస్ట్ కన్స్ట్రక్షన్ పార్ట్. First construction part consists of primary winding, secondary windings. Across primary winding, I am going to apply some AC excitation signal. Across secondary windings, I am going to obtain some potential here. Those potentials are ES1 and ES2. Okay, depends upon the arm displacement. The variation in the secondary winding will takes place. Secondary winding potential levels is going to be varied. This is the another type of diagram. This is the primary winding. I am going to give some input voltage here, that is E in, and I am going to obtain across the secondary winding output voltage is E naught. Okay, that is ES1 and in terms of ES1 and ES2. That E naught is equal to ES1 minus ES2. Depends upon the displacement of this arm. If the displacement is left hand side towards the core material is more at across this secondary winding S1, then ES1 is greater than ES2. Okay, this is positive. This is positive value, and this is going to be small value. Therefore, output voltage is going to be positive here. Then the phase difference is going to be positive only, not like that. Okay, here if this core material is going to be moved towards this secondary winding S2, then ES2 is greater than ES1. ES2 is greater than ES1. Then the phase difference will take place, and that phase difference is going to be like this. First A point, if core material is if the core material is more across the left hand side, then the phase angle is 0 degrees. If the core material is moved towards the right hand side, then ES2 is greater than ES1, then the phase angle is 180 degrees. Then the phase angle is 180 degrees. Here this is the A position, this is the, let me draw this one, this is the A position, and this is the B position. Don't get confused. Okay, this is the A position and this is the B position. Phase angle is 0 degrees and this phase angle is 180 degrees. Okay, this is the residual voltage. Why this bend I am getting here means beyond this 5 mm, beyond this 5 mm displacement I am applied here, then the curve up to this one, this is below the 5 mm, I am going to obtain linear curve. Beyond this 5 mm, I am going to, the deviation of this curve will take place. Okay, this diagram is very important, and the entire working depends upon this diagram only. Okay, this is the normal normal experimental point of view LVDT. This is the view, advantages and disadvantages of LVDT and applications of LVDT. In this way, you are supposed to reflect the entire topic in your exam in this way only. Okay, then we can score more marks. Okay, this is about linear variable differential transformer. Very important topic. There is another topic is also there. If you are interested, RVDT. This is not in your syllabus. RVDT, that is rotary variable differential transformer, like that. By this by this we have completed linear variable differential transformer. In the next class we will see the new topic, like that. Okay.